My name is Jeff Bryant. I work for Wolfram Alpha, and I'm giving a talk on AnatomyPlot3D. In a sense, this is kind of an extension of the presentation we gave last year, which was about anatomy data. Keiko here is sitting up here in the front row. She actually kind of oversees a lot of our anatomy initiatives. I work on just mainly the graphics portion. So if you have any questions about anatomy, she might be able to answer those questions. If you have questions about the graphics, probably more me. So with that, we'll get started here. So the origins of AnatomyPlot3D pretty much started last year when we came out with anatomy data. Anatomy data has a lot of different properties for anatomy entities, heart, left femur, bones, muscles, you name it. But only one of those was graphics 3D. And we provided that last year in version 10. And it allows you to download 3D models as graphics 3D objects for each of these anatomy entities. And I think we have something like 4,800 different 3D models, I believe, something on the order of that anyway. And that's where everything started. And that's all fine and dandy. You can download these models. You can rotate them, just like any other graphics 3D object. But essentially, that's the end of it. I mean, it's a graphics 3D object just like any other graphics 3D object. You can do graphics programming on it. But if you don't know the structure that's in there, it's kind of really hard to get in there and manipulate these things and do anything you might want to do to annotate them or highlight certain substructures, anything like that. So, but as you can see here, the graphics 3D property returns graphics 3D heads. But it contains metadata. And this is something you may not know by looking at the model because they're kind of hidden and embedded in there. And here you can see that I've asked for the graphics 3D of the left hand, and I've said turn all the annotations into tooltips. And so as a result, see if the tooltips are working here. Yeah, there you go. So you can see here that it actually highlights each part with what entity it's made up of. And that's the metadata that's actually buried inside these models that allows it to know what they're made of. And this is actually very important for the eventual development of AnatomyPlot3D, which allows you to then investigate the inner structure of some of these things. And just to give you an idea of some of the metadata that's buried in here is, here for example, we did the left thumb. I just did a smaller example. And I said, give me all the annotations that are buried in here. And you can see here that we have a number of annotations for all the different subparts that includes the name of the entity itself that corresponds to that, also source information, so you can see we get our models from Body Parts 3D, and also from the Unified Medical Language System, they have a unique identifier, the UMLS concept ID. And so we've incorporated that in there as well for anybody that might be familiar with the UMLS. They can easily align these concepts. So that's the graphics 3D portion. Now, in order to allow you to explore these models a little bit more instead of them just being kind of a dead end, we needed a way to extend the graphics 3D language. Graphics 3D language has been around for a long time, follows very well-behaved rules. And so we just wanted to build on top of that. But the problem is the graphics 3D language does not know what an anatomy entity is. What we wanted is something that allowed you to essentially use the language that already existed, but refer to these things almost like they were primitives, like a sphere or a cuboid or something like that, and be able to apply the same styling that you might to those types of things. But graphics 3D is very heavily tied to the front end. And so sphere is known natively to the front end as something that can be rendered as that graphical thing. Anatomy entities just format as a yellow box. It's not going to know that it's supposed to be some kind of a model, and it's certainly not going to go fetch the model and download it. So we wanted to extend it, but we did not put it within graphics 3D itself. So we came up with AnatomyPlot3D. So here you can see an example, just a very basic example, AnatomyPlot3D of just the left femur. This is essentially, when you use a simple form like this, is pretty much just like asking for left femur and then say, give me the graphics 3D property. At this level, they're almost identical. It's just a magic wrapper that does that for you. But it allows you to do things that just retrieving the graphics 3D property wouldn't allow you to do. And once again, it follows pretty much the same rules that the graphics 3D language does with some additions. So here's a basic example. So imagine replacing each of these entities with a sphere, and you would get a very similar type behavior. So here you can see, we've got a red left femur, a blue right femur, and then we've even got some scoping here. So we've got a list here where the hip bone is yellow, Now we jump up back out of that list, and we ask for the sacrum, and it falls back to the blue color that was back here. So it allows you to style these entities just like they were primitives in the Graphics 3D language. But as before, the head of the result is still Graphics 3D. So if you wanted to, you could still go in and do whatever Graphics 3D programming you wanted. It's just a convenience thing. It's kind of like Plot3D returns a Graphics 3D result. But it allows a lot of evaluations and options and things like that that can allow you to evaluate and get a lot more power out of it. Basics of AnatomyPlot3D. So it is an extension of the Graphics 3D language, and as such, you can combine regular Graphics 3D language primitives along with these entity references. So here you can see I've combined the left femur, and I've also just included just a regular Graphics 3D cuboid. It's a very simple example. It's not really all that applied, but it does show that you can mix the two things together. And it also takes the same options as Graphics 3D. However, we have a lot of convenience things that have been added. So here you can see we've got the left hand, the right hand, and then we're telling it we want to draw a line from the left hand to the right hand. So what we've done is we've actually extended a lot of the Graphics 3D primitives so that they can actually take entities in their location arguments. So any place you might expect a Graphics 3D language to take like a sphere, where do you want to place the sphere? You could put an entity there if you wanted, and you would end up drawing a sphere at the location of the left hand or the location of the left femur. So that's kind of a convenience that you can actually kind of mix the two things together. Another example here, you can see where I've done skeleton on the right hand that shows you can annotate things. So here I say draw a red arrow from this coordinate to the right fifth metacarpal, and then also label it with some text. And so I've mixed, once again, Graphics 3D with some of the anatomy concepts. So this really is just an extension of the Graphics 3D language. Now, those were very simple examples, just to kind of give you an idea where we're going with this. But it became very clear for especially some of the larger structures like the hand or the left leg or something like that, where you have many different tissue types mixed into one structure. We wanted to be able to dig in and kind of manipulate the inner structure without having to ask for the individual things that are added up and build it up from scratch. And in order to do that, we came up with a new structure or a new language element called anatomy form. And this really only has meaning inside of AnatomyPlot3D. It does not apply to the Graphics 3D language. It only applies to anatomical entities that are in the argument. So here you can see I've said anatomy form, edge form thick blue. So, and then left femur, and I put a cuboid. And notice that it's only applying the edge form thick blue to the left femur. It's not applying it to the cuboid, which is right here. So anatomy form only applies to the anatomy elements. You could also just use edge form thick and blue, and it would apply to both. But if you use anatomy form, that's kind of a way to say just do it for the anatomy stuff. But anatomy form has some additional forms that are a little bit more useful, and this is the part that allows you to dig in. Anatomy form takes an association. And here you can see I've said give me the left hand, but the preceding anatomy form says make the bones blue and make the muscles green. So with very short syntax, I've been able to dig in without having to query for the individual structures manually. I've just been able to specify essentially the tissue types, which themselves are entities, and just said color all the muscles blue and all the muscles green and all the bones blue. Another similar example here, we've got the left arm, and we want the so up here's a good example of tissue types where muscle and bone. Here we've dug in and we've actually specified individual muscles. So here, long head of the left biceps brachii is green, and the short head of the left biceps brachii is blue. So it allows you to dig in at multiple levels, not just at the tissue type level, but you can refer to individual actual entities, not just their kind of parent tissue types. So here's just a little fancier example. Should be able to enlarge this, I think. Make it a little bit bigger so it's easier to see. So this is kind of an X-ray effect. And so what we've done is we've designed a custom light source here called reverse lights, where it's essentially just got a single black ambient light, and then we've got a table of directional lights. It's a ring of lights that we've set up behind the scene. And so that allows things to look backlit, kind of. So you get kind of an edge, but then everything in the front kind of has a black look. And then in addition, we've combined that with anatomy form. And here you can see we're asking for the left arm, but the preceding anatomy form right here says make the left humerus red, but the underscore here indicates everything else should have this directive, which has a certain specularity, certain color, and then it has the lights that we told it to use. So essentially it kind of gives you this X-ray-like effect. We're hoping to improve on this in the future, actually, and kind of have some named directives so you don't have to build some of these things out. They're kind of like themes, almost like plot themes, but they're done at the directive level as opposed to globally for the whole scene. I'll mention a little bit more about future directions at the end of the talk. We've actually got a couple options that that take advantage of these entities. So here, for example, plot range, which is something that works in all graphics 3D. You can actually specify an entity for your plot range. So here we've said, give me the left femur, the left tibia, the left fibula, and the left patella, but make the plot range only the left patella, and then give it some plot range padding. So essentially, you've said, pull in pretty much all the major bones of the leg, and by default, you would see all of them. But now we've said, but make the plot range just the patella, and just pad it out a little bit. So it kind of allows you to zoom into a particular feature of interest. We've also got an option called skin style, and this is more of a convenience option more than anything else. By default, most of these structures will not pull in the parts of the skin that correspond to them. The skin is kind of its own separate thing. It's not considered like the skin here is not part of the left hand by default, but you can by default, you can say skin style goes to automatic. By default, it's none. And it will pull in kind of a default transparent, the skin that overlays that particular part for you. And if you don't like the default style, you can actually override it. Here I've said, give me the right hand, but make the skin style transparent blue. A little bit of a side, something that we added in version 10 for the Graphics 3D language, not just for anatomy, but Graphics 3D, is clip planes. This is an option you can use for any Graphics 3D that allows you to apply clipping planes. It doesn't actually modify the underlying polygons. It's purely done in the front end, and it actually allows you to cut across entire structures. Okay, so here you can see an example of what we supported in version, sorry, I've lost my mouse here. There it is. You can see here we've added the clip planes option to the whole scene, and it's cut through both spheres here, a red and a blue sphere. But in version 11, we added the ability to have clip planes be directives. So kind of in the same way that lighting can be a directive and apply to only certain elements in the scene, you can do the same thing with clip planes. So here, we've got the same two spheres, but in this case, the clip plane only applies to the outer red sphere. This was very useful to us for anatomy because we wanted to be able to cut away, for example, muscle and skin, but still be able to see bones and stuff. So we were really pushed for this feature to make it into 11, and we're glad that it did. Oops. It's spinning here. So here's some more applied examples where we've used clipping planes on some anatomy. So here you can see we've done the entire left upper limb, but we've put a clipping plane and then the skin of the left upper limb. So you can actually see where you can kind of do these cutaways and reveals and see the structures that are underneath. Here's a more complicated example where we've done it for multiple structures. So here we've done we've cut the muscles. You can see that it's part of the directive for the muscles. There's a clip plane in there. And then similarly, we've got the skin with a different clip plane. And then we've got the bones. Something else that you can do is not just the primitives, but also the geometric transformations. So here you can see we've got to rotate. Mouse isn't behaving here. There we go. So here you can see down here at the bottom, we've got 3 different skulls, or it's the same skull in all cases, but what we've done is we've applied a rotation transform to the mandle and the mandibular dentition. And you can actually modify these, and you can see that I've rotated them around the temporomandibular joint. So I've specified this as the rotation point, and I've essentially just given it 3 different rotation angles at 0, 10, and 20 degrees. And so on the left, you see the jaw is closed, and it opens up a little bit at 10 degrees, and then another one at 20 degrees. And you could actually animate this, and you could actually use to manipulate where the jaw opens and closes. These are just some advanced examples here where you can see how far you can push it with some really highly stylized models and stuff. These are actually bitmaps. I didn't leave them as models because with this many polygons, and I will mention that, for anatomy data and anatomy models, these models are not small. They are big. So if you're planning to use them, keep that in mind when you're trying to download them. They are not going to come up just like that. These are not just simple. We may in the future try to optimize them a little bit, but the goal here was to go for kind of quality and detail. These are not low poly models with textures. These are high poly models that they get their detail from the number of polygons, not from some texture that's on them. So big examples like this, you've got a lot of polygons in here, plus you've got transparency in 3D. So this can take some time to render these as well. So just keep that in mind if you're going to ask for large structures and start doing things like rendering them with transparency. It may take a little while. So here I've actually converted to bitmap just for the sake of expediency. Got a few more minutes here. So these are so that was that top example. I forgot to show the ones down below here. So here you can see some additional examples. We have organs, we've got muscles, we've got bones, cartilage. Tim Shuttlebauer's in here, I think. Yep, Tim's over here. So Tim was really useful, and actually Keiko did a lot of the alignment. So when we had to, of course, we had different sources for the models than from the entities. And so we had to align these, and Keiko was very useful in actually aligning these two things so that we knew which models went with which thing. And then Tim actually was very helpful in helping us go through each of the tissue types, and in some cases overwriting individual organs so that they had colors that were a little bit more illustrative and obvious to people. So we had to manually color all these models ourselves because originally it was just geometry that we obtained. So here you can see the torso with some of the organs in there. And here's an example where we have clip planes once again, where we've kind of shown the entire left upper limb, and we've kind of just cut away the muscles, but we didn't get rid of them entirely. We have two clipping planes in there, and on one side everything is their normal solid color, and on the other side they're that kind of transparent backlit look. So it kind of does a wipe. You could actually animate this, and actually I've got an animation I'll show here in a few minutes where you can see that. And then here's another case here where we're showing some inner structure of the brain. Even though the brain is not the largest physical size structure, the model of it is actually quite large because it's extremely dense. There's a lot of internal structure you don't necessarily see if you just see the outer model. All those internal structures have their own models and they're all part of it. So when you download the brain, it's actually pretty decently sized even though it's not physically the largest. Okay, so some future plans of things that we're planning to do. I kind of touched on this a little bit earlier. We're planning to have some kind of name directives. You saw where I was creating these custom lights, and that can get kind of messy. It'd be nice if we had kind of this idea of, it's kind of like plot themes, but at the directive level. But we need some themes that are more anatomy targeted, things like X-ray, things like that. So we're trying to come up with ways to have kind of string named anatomy forms for convenience that would make it easy to do those kind of styles. There don't seem to be all that many. I've kind of looked out there at different anatomy visualizations. They all tend to use that kind of backlit, transparent look more than anything else. But we're trying to see if we can come up with any others as well. We are also planning to support plot theme X-ray. So I think I'm going to be working with Tim in the near future to actually come up with making plot themes work with this. So I guess we'll have a business form for the brain. We'll see how that goes. Here's a few videos. I'll try playing these. I don't know, should I try these? I guess the network should be good. So here you can see where I've rotated I've done the rotation transform just over, there's about 300 frames in this animation, so it's nice and smooth. Okay. Oh, so used to Windows, not used to on the Mac. Everything's on the left. There we go. Back to my talk again. There we go. Some of these animations are ones that we went to SIGGRAPH this year and use these as part of the display there. So we've got a number of tissue types and different styles and cutting planes and stuff, kind of revealing things that are inside. Okay. Let's see here. Some of these I've seen. I'll come back to the others as time allows. I think we still got about 10 minutes left here, so we jump to ones that. So you saw screenshots of some of these already, so I'll go to some ones here. This is one we actually just created the other day where we took all the bones of the skull and applied a scaling transform to all of them. So. I tend to prefer looping animations, the ones that just kind of come to an end, just kind of stop, and it's like, ugh, kind of jarring. But we threw it together very quickly yesterday, so. This one here, I showed you a screenshot of this where I just did one frame from it. Here you can see where we kind of wipe away the muscles, but they're not actually disappearing, they're just changing their style. So they're still there, they're just kind of transparent backlit. Okay. This actually was quite challenging because I mentioned that the brain was one of the denser structures that we actually have. And this became tricky for the front end because by default, the rendering mode used by the front end has a certain number of, it's got a depth specification. And the number of polygons we're looking through was so high that it wasn't rendering quite right. So I actually had to add an option, a front-end rendering option that's actually, you'll see it in the notebook. The notebook will be available that has these. But it allows you to actually go through more polygons here to see all that internal structure without rendering artifacts. So it's kind of the hind brain and all the inner structure there, or I'm sorry, the midbrain, not the hindbrain, the midbrain and some of the surrounding structures around the midbrain, brainstem. And some of these take a long time. With all the polygons, this took hours. This was something I kicked off at night, kind of went to bed and woke up the next day and kind of continued to monitor it. So it took hours. That was like 600 frames in that animation, so it took a while to get it that smooth, the transparency and everything. So we're kind of more than halfway through the conference now, so there aren't a whole lot of visualization talks that are left, but there are at least a couple that might be, if you're interested in this, you might be interested in going to. I'll mention the custom entities talk that's actually coming up on Friday at 10 o'clock. It's not directly related to this, but we are making use of the anatomy entities here, and there's a lot of other entities, and you may want to expand onto your own entities. You may want to add your own, and Tony's giving a talk on how you can actually create your own entity stores and kind of expand entity values so that you can create your own data sets. So not just use the ones that we provide, but create your own. And then also, Yutsu is actually going to be giving a talk on Friday, later in the afternoon, 4 to 4:30, on 3D graphics in general, and I'm sure he'll probably mention the clip planes, which I mentioned here, and any other improvements in the front end that have happened for the graphics 3D language there as well. I've got a few links here at the bottom. It's mainly for documentation, but we've actually got some knowledge base expansion. You can see there some of the anatomy models were used there. We've referred to this guy as Entity Man. You can't really see it here probably because it's not zoomed in enough, but these bands that run across here, the skin, are textured with a whole bunch of entities, so you can actually see entities wrapped around him. Michael Trott created that one. So we've got a number of other examples, some of which are anatomy, but you can see some of the other data sets that we've made use of. And then also a number of other new visualization domains, not just anatomy, but lots of others. So you've probably, if you've been to any of the other visualization talks that have already happened, you've probably seen some of these used as examples. Lots of word cloud, cellular automata, there's the anatomy stuff. So that's basically all I've got. Any questions? Yeah. We still have time, I assume, right? Yep, okay. Yep. Any questions?
Is there any plan to add also other organ sizes let's say, because that's a perfect body, isn't it?
Well, Keiko's actually been to the company that actually provided the models. We didn't create these models in-house. These are actually provided by a company called AnatomyPlot3D, and they're based in Japan. They're kind of an idealized person, right? And they're not made from one person. These are not something that are made from a CAT scan. They're not volumetric models. They're all surface models. But they're kind of a hodgepodge of multiple people. Is that correct? And then the guy who puts these together manually tweaks these things so that they actually all fit together. So it's kind of an idealized person. We actually did try a first data set that was actually, I think, Visible Human or something like that. And that was volumetric, where a guy had donated his body to science. And when he died, they froze him and then sliced him in 1 millimeter slices from head to toe. And then they scanned each slice and then tagged every pixel as to what structure it corresponded to. And we actually tried building the surface models from that volumetric data, and it kind of worked, but number one, it really looked like a guy had been left out on a slab a little too long. It wasn't real attractive to look at. He was not a perfect individual. He was missing some parts. Steven's kind of squeamish, actually. Didn't really like looking at them, and the data sets were actually quite huge. The volumetric data was a bit much. It was very cool, but these models are just surface models, and they're already large to deal with. If we had pushed forward with that, it would have been really hard for, I think, a lot of machines to do the entire thing as volumetric models. So, but there are more models coming. There's just one size. At some point, we hope to have the female, but right now, I don't think they even have the female. Is that correct? Yeah, they don't. The company that we get these models from doesn't yet have a female, but we're hoping to eventually add those as well, to have 3D models for that. And I actually was just told that she heard from them yesterday. They have some additional muscles, things like that. Some of the smaller structures are still missing. We don't have everything yet. So like facial muscles, there's a lot of facial muscles we don't have yet, and some of the smaller nerves, veins, things like that. So as he has time, he provides them and we incorporate them in. So we're hoping to expand those. Yeah? It would be cool. I wouldn't say there's currently plans to do it. Maybe. Maybe. Yeah.
Is there any possibility to use those models also for biomedical applications, so that you might introduce matches on the models, and then you can solve like elasticity problems with bones or...
Well, we have an example of that. We've had one since actually anatomy data came out. Michael Trott came up with this example where he actually took the transcending colon, just the top part of the colon here, the horizontal part, and he actually used the was it ND eigenvalues to actually find the oscillation modes of the transcending colon. So we have a vibrating colon in our documentation examples.
Do you have by any chance for the upper respiratory tract, let's say the lungs and the trachea or something like that?
They're in there. The models are in there. And you can do any computations you could do on any other model just like you could with anything else. I can't speak to exactly how detailed the little brachii and everything are, the tiniest structures, but you definitely see them. If you plot the trachea and you plot the lungs and stuff, you'll see a lot of that in there. I can't speak to the exact detail and the tiniest structures in there, but it looks, they're actually pretty decently sized, so I'm guessing the amount of detail in there is pretty high. We've actually been in communication with a guy that's actually doing electromagnetic, he actually does study on electromagnetic like tissue penetration for like if you're going to model how deep a CAT scan or something like that would go into a particular type of tissue, he actually models that. And we're actually probably going to be in talks with him to try to incorporate some of that information so that we have more physical information. I should say that when I showed that model of the moving jaw, that's easy because the bones are rigid structures. What we don't have is any mechanical information that, wrapping the talk up here, so we don't have any mechanical information about muscles, how they bend, stretch, things like that. So if you tried to make a moving model of that, they're just going to separate. If you tried to move them, you can rotate them, but they're going to act like a rigid structure. So it's easier to create animations of bones moving, things like that, but not necessarily with the muscles. That requires a lot more data that the models themselves don't have that information. So they're not allowed to stretch. So. All right, I can take any additional questions outside in the hallway or downstairs, but I want to wrap up so that the next speaker can come up here. Thank you.